Scatter plots are graphs that are used to determine whether there's a relationship between pairs of data. For example, if I talk about if the x-axis represents the number of days we have school, and the y-axis represents how many animals are at the zoo. Is there any relationship whatsoever between the number of days we have school and the number of animals in the zoo? No, there's no relationship whatsoever. Another word for relationship is correlation. So that would be an example of relatively no correlation, if the points show no linear pattern whatsoever. So that kind of graph would look something like this. A scatter plot is a graph where the points are scattered. Positive correlation, the y values tend to increase as the x values increase. The scatter plot shows a line type of a pattern that looks like a positive slope line. Negative correlation is when the y values tend to decrease as the x values increase. So it looks like a line with negative slope. A best fitting line, are you ready for this definition? A best fitting line is a line that fits the data the best. Really, it is. I know, crazy. Steps to approximating the best fitting line. We are going to start by carefully drawing a scatter plot of the data. You want to use an actual piece of graph paper, and you want to think about your scale so that you can make your graph as accurate as possible. So we're going to start with step 1. Let's plot the data on this graph. My smallest x value is -2. My largest x value is 5. So since there's negatives and positives, I am going to use the center point as the origin. So this is my x-axis, and up here is my y-axis. Now I see a whole bunch of like 0.5s, so perhaps counting by halves would be nice. So here's 1, 2, 3, 4, 5. Keep going, labeling all your axes. Once you have your axes labeled with your scale, now carefully plot each of those points to create your scatter plot. So -2, -1 would be right here. -1. Oh, yeah, you're right. You know, I'll just graph this totally wrong. I was checking to see if you were paying attention. Keep plotting your points. Now that we have our scatter plot, I have a question for you. Would this be considered a best fitting line? Let me get my ruler on here.
No. What is that?
Why is that not a best fitting line? If you're watching the video right now, I'm wondering if you can actually hear my class right now. They're kind of going nutso on me. That is not a best fitting line. Okay, so let's look at step number 2 up above. Sketch the line that appears to follow most closely the pattern given by the points. There should be approximately as many points above the line as below it. And this is what's really most important. The space between the points and your line should be somewhat equalized. Like, envision trying to find the distance between each point straight to the line and try to make that as similar as possible, even out the space. So if there's one point, like this one right here, that I just dotted with red, that one is kind of farther away from the rest of the pattern. So that one might be farther away from your line. That is okay. So I'm going to try to draw in a line. You want to make sure you use a straight edge to draw in your line. try to match the slope. You do not need to go through any of the original data points. If you don't hit any of the original points, that is totally fine. So let's see if I can make a good line here. How's that line? Is it better? Okay. I've got about 5 points below the line, about 5 points above the line. Now this point down here, the 3.5, -3, that is a little bit farther away from the line, but that's okay because it kind of has equalized. Okay, the next step is going to be very different because your line is different from my line. The next step is choose 2 points on your line and estimate the coordinates of each point. These 2 points do not have to be original data points. In fact, it is often better if they are not original data points. Now use the graph to help you. Look for places where the line crosses the grid like perfectly. It's not quite perfect. Right here looks a little bit better. The other thing is you should really try to make sure that you pick 1 point from like the upper part of your line and 1 point from the lower part. Try not to pick 2 points that are too close together because that will affect your accuracy of your slope. So down here it looks like, ooh, there's a good one. So my points are -1.5, 4, and 4.5, -2.5. Okay. Your next step, once you have 2 points found on your scatter plot, is to find the equation of the line that passes through your 2 points. So you're going to have to find the slope, use the slope in one of your points in point-slope form, get it into slope-intercept form. So take a moment and do that with your points, because your points are probably different from mine. My equation is y equals -1.08x plus 2.38. Decimals are definitely fine for this because this is a more real-world situation. According to the graphing calculator, this is actually information about the next one. According to the graphing calculator, the correct perfect line of best fit is -1.11x plus 2.27. So my line was pretty close. How would I grade this on a test? I would have an acceptable slope range and an acceptable y-intercept range, and as long as your line fell within those acceptable ranges, you would get full credit. So on this one, I would say an acceptable slope range would be anything from -1.5 to -0.75. An acceptable y-intercept range would be anything from about 1.9 to about 2.6. So if your slope and y-intercept are somewhere within that range, you're good. If they're really, really close to that range, you're still probably good. On the next page, this data represents the number of minutes after takeoff, 1 through 10, and the miles per hour of the plane, how fast a plane is moving for the first 10 minutes after takeoff. First thing we need to do is plot this data. Now, do you see any negatives in this data? No. So I am going to use the bottom as the x-axis and the left as the y-axis. Since we don't need any negative values, we might as well use that far bottom left point as the origin. We're going to use the whole thing. We might as well not have any wasted space. The next thing is our x values go from 1 to 10. If we just use each of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we're going to end here, and we've wasted half of our space. So I'm going to count by halves again to really maximize the space and make things as accurate as possible. Okay. For the y-axis, you do not have to start at 0. We can start with 180. We just have to put this little symbol on the y-axis to indicate that we shrunk down that y-axis so that we zoomed up to see this new data. So I'm going to start at 180. We have to decide how to count. 50s is, I think, too big, so let's do 20s. 180, that'd make this 200, 220, 240, 260, 280. That would make this 300, 20, 40, 60, 80, 400, 20, 40, 60, 80, 500. Once you have your axes labeled, plot your points as accurately as possible. 180. Once you have all of your points on the graph, you need to use a straight edge. Make sure you're not freehanding a line of best fit. You need to use a straight edge so that your line is actually accurate, and draw in a line of best fit. Okay, here's my line of best fit, and I think it might be a little bit low because these 4 points here are a little bit high, but it'll work, I guess. And to find points on my line, that would be a good one. Here's one. And up here, how about there? Now notice the second point is really close to one of the original data points, but I did not use that data point because that point is not on my line. You want to use 2 points that are actually on your line. So my points are 4.5, 340, and 9, 500. Okay, you need to find the slope between your points. You need to use the slope in one of your points in point slope form and then get it into into slope intercept form. So take a moment and do that whole process. Okay, the equation that the calculator gives you if you actually type in the data and have the calculator crunch the numbers for you is y equals 37.45x plus 172. Remember, you need to pick your points. They need to be points that are actually on the line, not data points that are nearby, but points that are actually on the line. Find your slope. Use your slope and one of your points in point slope form. Distribute your slope. Get y by itself. An acceptable slope range would be anything from 32 to 42. An acceptable y-intercept range would be anything from 160 to 184. If you're on the higher end of the slope, you're likely on the lower end of the y-intercept. If you're on the higher end for the slope, you're likely on, did I just say that the same thing again? If you're on the lower end for the slope, you're on the higher end for the other. Yeah, I don't know what I'm saying. If you're closer to 32 for the slope, you're closer to 184 for your y-intercept. If you're closer to 42 for your slope, you're probably closer to 160 for your y-intercept.